Okay, so welcome to our session for today. So we're going to discuss now the limit of a function. So we have here the following learning objectives. At the end of this module, you will be able to, number one, evaluate the limit of a function using the limit theorems. Then define continuity at a point and on an interval. And then we distinguish the difference between the continuous and discontinuous function. So let me start with the limit of a function. So it is the backbone of calculus actually. So it facilitates evaluation on what is happening to a function as it approaches a certain point. The limit of a function is a fundamental concept in calculus and analysis concerning the behavior of that function near a particular input. So it might be recalled in your functional notations topic that in every independent variable there is a corresponding dependent variable or vice versa. So as we substitute a certain independent variable, there is a value for that dependent variable, and that value is actually changing. That is why it is called a variable. So the limit of a function facilitates what is happening on that function. So as a notation, we have here the left hand side and the right hand side. So we have here the left hand side is the function itself, and L here is the result of that function when series of x or variable x values are substituted when it is approaching an integer. So it is being read as limit x approaches a function of x is equal to L. So this is the limit as x approaches the integer, and this is actually the left hand side which represents the function of x, and the right hand side which represents the value of the function given x approaches the integer. So the function could be either continuous or discontinuous, and that is termed as continuity and discontinuity. So by the term itself, it simply means that in every value of the independent variable, there is a corresponding value for the independent variable. This is a graph where there will be no holes or no gaps. As an example, if we have a function of y is equal to x cubed, there will be a continuity wherein this arrowhead reaches infinity on the Cartesian plane. So when we say infinity, there's no limit. That is why there is an arrowhead going up and going down. So whatever values of y, there is a corresponding values of x. So in short, in informal terms, the graph could be written, could be drawn without lifting your pen. Okay, so there will be no discontinuous points. So for continuity, we can check whether our equation is continuous or not. So in short, the three criteria must be satisfied. Otherwise, if one cannot be complied, therefore your function is not continuous. So number one, that the function of a should exist, and then the limit of the function x also exists, and then the limit as x approaches an integer, the function of x is equal to the function of that integer. So let us have some examples. We check the equation with the listed criteria. Fa exists, the limit of fx exists, and the function and the limit should equate. Okay, for the first problem, so at x is equal to 1, should this function exist? So let us check for the first criteria. So letter A, for number 1, letter A, we have 11 times 1 squared minus 2 times 1 plus 6. So the function 1 is equal to 11 minus 2 plus 6, and that should be equal to 17 minus 2, that is equal to 15. So it really exists, so we're gonna check this one. Okay, and then if the limit exists, if the limit as x approaches 1, the function 11 x squared minus 2x plus 6, so we simply substitute the value 11 times 1 squared minus 2 times 1 plus 6. So therefore the function is also equal to 15. So this is for letter B, and again this would be a check mark there. And then for letter C, really that the function of 1 equates to limit x approaches 1, we have the function 11x squared minus 2x plus 6. Okay, so that's for the first problem. So we're going to have the same procedure with the second problem. Okay, for the second problem, we have to check if f of 0 exists. For letter E, at x is equal to 0 and x is equal to 5. So we're gonna have the solution simultaneous with the two values of x. So starting with x is equal to 0, so f of 0, this is 10 over x minus 5, or 10 0 minus 5, or this is equal to negative 2. So we have a check mark for the first, and then for the limit we have f of, see, the limit as x approaches 0, we have the function 10 x less 5. So the same procedure, just have to evaluate the limit we're in. We set an x that is approaching 0, so just the same, we have negative 2, and that is for letter B. We put a check mark on letter B criteria, And lastly, letter C, we found that f of 0 is equal to that limit of x approaches 0 with the function 10 x less 5. So all criteria are met, hence we can say that x is equal to 0, we have a continuous function. Okay, we have a continuous function. So we can place here it is continuous. Okay, so we do it the same procedure with this x is equal to 5. For the first criteria, if the function of 5 exists in that, so we simply substitute 10 all over 5 less 5, hence we have here 10 all over 0. We have an undefined value. So for the first criteria, our value is undefined, therefore the function of 5 does not exist. So we place an X mark on that criteria. For the x is equal to 5, this is already x. We do not continue, because once there will be a criteria that will not be met, then we can say that the function is discontinuous, or the equation does not exist, DNE. Okay, therefore the equation does not exist, DNE, at x is equal to 5. Okay, so that is how to do continuity test for number 2. Okay, for the third problem, we have the function of x, 2x all over x squared minus 4x plus 3 at x is equal to -1 and x is equal to 3. So for x is equal to -1, perhaps we have function of x which is -1, okay, 2 times -1 times -1, this is squared, minus 4x plus 3, okay, this is equal to -2, then this is +1 minus 4 times -1 plus 3, then we have here -2, 1 plus 4 plus 3, so we arrive at an answer equivalent to 2 all over 8. So we put a check mark here, first criteria, and then for the second criteria, it is just the same one, we just have to change the notation, but this time it is approaching, that x is approaching -1, so we can say that limit of x approaching -1, and then place the function. We have 2x x squared minus 4x plus 3, and then certainly it will arrive to this -2/8. Again, that is a check mark for that criteria. And the third one, we have really tilde f -1, the function of -1 equates to the limit x approaches -1 with the function 2x x squared minus 4x plus 3. Okay, so we satisfied all three criteria. Therefore, we can say that at x is equal to -1, it is continuous. Okay, so that's it for that problem. And then for our x is equal to 3, we have x is equal to 3, function of 3 is equal to 2 times 3 all over 3 squared minus 4 times 3 plus 3. So we have here 6, this is 9 minus 12 plus 3. So 9 minus 12 plus 3 will yield to 0. So when we have a divisor equal to 0, therefore this is undefined. So again, this is an X mark for the first criteria. Okay, so we do not want to continue because we have already established that therefore at x equal to 3, the function does not exist, or B and E does not exist. Okay, so that's it for the solution of this problem. Now that we have already know how to evaluate continuity in a function, let us also discuss principles of discontinuity. So if the equation has an unidentified value, it is discontinuous. So there could be two types of discontinuity. So number one is we have the essential discontinuity. If at x is equal to c, the left hand side of the equation, which is the limit x approaches c, function of x, does not exist. There are different values at a certain point where functions approaches that point from left portion and right portion of the equation. So here we have two functions. It is noted that at a certain point along x, these two functions behaves differently. So this left function, or the functions from the left portion, approaches this line, or that is between 0 and positive 1. So same true with this straight line. So in that case, given this scenario, therefore there will be no value for this, because if we can see here, okay, this is an open circle, or meaning that is an open circle does not have a value for this particular line at x, but this right function does have. Okay, so they both are approaching this line. However, there will be two different functions. So that this is an indication where essential discontinuity exists. So essential discontinuity normally are not removable. So there are two types of discontinuities, essential discontinuity and removable discontinuity. Essential discontinuity refers to non-removable discontinuity. When we say non-removable, it cannot be repairable. So by and by, we will elaborate that one. Okay. So that's it. The left function and the right function behaves differently. Hence, they have two different values at a certain boundary. So in that case, this is discontinuity. So we will know what type of this essential discontinuity that is. So as an example, this is another type wherein these two functions approaches for looking at the piecewise. When we say piecewise function, there are sub-functions. You can see here in the piecewise expression that x plus 1 is a function if x is less than 4, but x minus 4 squared plus 3 is another function if x is greater than or equal to 4. So x is less than 4, meaning this is a function just left of 4. Okay, just left of 4. But it will not have a value for x is equal to 4. Okay, so if we do that, if we directly substitute 4 here, x will have a value of 5. 4 plus 1 is equal to 5, but it will be expressed in an open circle here. It is being expressed in an open circle, okay, because x could never be equal to 4. Okay, and then there will be a corresponding value also on the right portion. This is greater than or equal to. Greater than meaning just right of 4, including 4. Okay, including 4, all of the functions are to the right. And we observe that there will be continuity on both left side and right side functions. Left portion and right portion will have a continuity away from the 4. However, approaching 4, okay, as we approach 4 here, they behave differently because they do have value, but on the other one does not have. Okay, so it behaves differently. Hence, there is no continuity between the two functions. Hence, this is an essential discontinuity. Okay, essential discontinuity could also exist in radical. Okay, in radical. So kapag may square root, and then of course kapag negative square root, ano na yan, it does not exist, or there will be a mathematical error on that. That is why you can see here that this function only lies on the first quadrant. If we are going to have an x which is negative on the left portion, it is found on the left portion, we will find an error on the function. Hence, this is another essential discontinuity. So, take note, kapag may radical sign, therefore, pag may negative integer sa inyong limit, therefore, that is already discontinuous, which is normally non-removable. that is non-removable. This can occur with radical expressions, inequalities, and piecewise equation or functions. Nakita nyo kanina, ano bang mga criteria yon na walang continuity? Sa piecewise, di ba? Essential, kapag sinabi nating essential, non-equality. Okay, ito, wala nang equality yan. Expect na wala nang continuity doon. Okay, so there will be no continuity if your symbol is greater than or less than. Okay, so no equal sign, that is already essential discontinuity. And then kapag may radical sign, that is already non-removable discontinuity. So lahat ng essential discontinuity is non-removable. So by and by, I will discuss ano ba yung removable at non-removable. Okay, so removable discontinuity, formally, a removable discontinuity is one at which the limit of the function exists but does not equal the value of the function at that point. This may be because the function does not exist at that point. A removable discontinuity is a point on the graph that is undefined or does not fit the rest of the graph. A discontinuity that can be repaired by filling in a single point. So, yung discontinuity, either ano lang yan, removable or non-removable. When we say removable, it can be repaired by filling a single point. Okay, filling a single point. I'll go back to this. Kung ito ba, mafi-fillan natin tong open na to, magdudugtong ba sila? So that is the question. No, it will not. So it will not be connected by a single point. So therefore, this is non-removable. You cannot repair this one by a single point, by a single dot. So yun yung point dito, class. Although yung removable, nag-e-exist yung function, at a single point, hindi siya mag-e-exist. As an example here, removable siya. Kasi ito will be having a graph involving this one. However, at x is equal to -3, this will no longer exist. Okay? But, if we graph this, may open point dyan na kapag finilan natin yun, it will have a continuity on it. So, that is a removable one. Unlike this, we have no way we can fill that open, or we can repair the function in order for that function to be a continuous. So in manipulation, in terms of manipulation of the equation, sa equation na lang tayo mag-concentrate aside from the graph, ano, yung removable is that we will have a way to eliminate the denominator. Okay? So, wag mo munang isa-substitute kagad yung limit when this exists. Kasi, pag sinubstitute mo agad yung -3 dyan, okay? Ang problema kasi dito, class, if the function is approaching -3, magkakaroon tayo ng discontinuity when x is equal to 3. Or sorry, when x is equal to -3. So, -3 plus 3 is equal to 0. So, kapag may denominator tayo na 0, that would equate to 0. So, if we are going to evaluate the limit further, the right way is that we are going to have a factor, binomial factoring here, and then we can cancel x plus 3. So, therefore, your denominator x plus 3 is eliminated. Hence, we can directly now substitute our value which is negative 3. So meaning the limit x approaching negative 3 here is with the function of that one. The answer is negative 3 minus 7, that is equal to negative 10. Okay, so that is the principle of removable discontinuity. So yung removable discontinuity na yan, this is the graph actually. So as x approaches negative 3, ito sinasabi ko, this is negative 3 approaching negative 3. May equation yan magkabila, coming from the left portion and the right portion. Only that kapag eksakto na dito sa negative 3, we will be having an undefined function. So therefore it will not exist at this x is equal to negative 3. So that is the principle of removable discontinuity. And usually it is called as point discontinuity. So point discontinuity, isang ano lang. Kaya nga sabi, if we have to fill this one, then continuous na siya. Okay, so that is the meaning of removable discontinuity. Discontinuous siya, pero pwede mong fillan yan at magiging continuous na siya ulit. So that is in graph. Pero in equation, it can be manipulated so that we can eliminate a denominator that would create an undefined value. Okay? So for non-removable discontinuity, so discontinuities that cannot be repaired by filling in a single point. So kaya nga may separation na. Kahit na maglagay ka ng isang point dyan, it cannot be connected. Okay, so this is what we call jump discontinuity. So we encounter jump discontinuity when we have piecewise functions. Yung kanina, yung mga piecewise, yung may mga sub-functions. Although this is not the only way to obtain a jump discontinuity. Jump discontinuities are called to be non-removable, okay, since the discontinuity cannot be removed by filling in a single point. As I have said, kahit na maglagay ka ng isang point pa dyan, it will not be repaired. So another type of discontinuities that we have, asymptotic or indefinite discontinuity. So we encounter asymptotic discontinuity when we get the undefined form and we get an asymptote. Yung asymptote is that there will be a boundary along x that whenever we are going to approach that certain boundary, it will not intersect that boundary. So tuloy-tuloy yan sa taas, pataas. But it will not touch this 3. Kahit napakalapit niyan, no touch siya sa line na yan. Same true with this. So magtutuloy-tuloy yan pababa. Okay? Magtutuloy-tuloy itong pataas, magtutuloy-tuloy itong pababa. Kahit na infinite pa yan, negative. Ito positive infinite. But it would not touch this 3 here. Okay, hence, if we substitute positive 3 here, undefined na yung value. It is non-removable. In a sense, hindi mo nga siya mapagdudugtong ng isang point. Kasi ayaw nga niyang dumikit dito sa line na to. So whatever happens, kahit na napakalaki or napakalapit mo na sa 3, hindi niya didikitan niyang value na yun. And that is non-removable. Secondly, there is no way we can factor out any terms so that we can cancel the denominator. That is why this is an infinite discontinuity, which is classified as non-removable discontinuity. Okay, so by examining this continuity, we make 4 conclusions. First, all polynomials are continuous, and then all rational equations in the form of fx or gx are discontinuous when your denominator is equal to 0, no? So if your denominator will be equal to 0, undefined na yun na, discontinuous na yun. And then all radical in the form of y is equal to the 8th root of function of x, a, 8th root, where a is an odd root. Kapag add 1, 3, 5, 7, 9, 11, 13, 15, basta odd number yung a mo, or the 3rd root, for example, that is still counted as continuous. Remember that, ano? So, kapag meron kang a is equal to 1, 3, 5, 7, 9, 11, yan, continuous pa rin yan. But, if your radical root is even 2, 4, 6, etc., that is no longer continuous. So this is discontinuous, and this is continuous. Okay, so we have polynomial. Kapag polynomial, that is continuous. Discontinuous if we have a 0 divider or the 0 denominator, undefined na yun. And a radical that is having an a root of even numbers. Okay. So as for our examples, so we have find all points of discontinuity, state the type of discontinuity, and determine if it is removable or non-removable. So this is a polynomial. Obviously, this will be a continuous one. Okay. How about this one? X minus 2, x squared minus 4. If x is negative 2. By the way, we can discover this if we are going to graph this one. You will find that the asymptote lies on x is equal to negative 2. Hence, that is asymptotic discontinuity, which is non-removable. When x is equal to 2, at point x is equal to 2, the asymptote has a discontinuity, hence that is still a point discontinuity, and that is removable. Kapag point discontinuity, parang open lang siya. Okay? Kung ito yung linya, parang na-discontinuous lang siya, na open point. So, yung point na yan, pwede mong i-fill. Okay? You fill that out so that it can be repairable, or that is removable. So, that is point discontinuity. So, this can be discovered that this equation is an asymptote at x is equal to negative 2, meaning the asymptote is infinity and it will not touch that asymptote at x is equal to negative 2. Okay, next, letter C. The function of x, the 3rd root of this function, x squared plus 2x minus 1. This is a continuous because we have a is equal to 3. Okay, this is an odd number, so it is counted as continuous. Okay, so for this one, this is a radical sign, square root. Square root is 2. Okay, a is equal to 2, therefore this is an even number. Hence, this is a radical sign which has a is equal to 2. Hence, if you're going to factor this, we discover that this is an essential discontinuity at x is equal to negative 2, and x is equal to positive 3. So within this boundary. So pinactor out niya lang yan and then equate it to 0. So each of this term will be equated to 0. Yun na yung boundary niya. X minus 3, like x minus 3 is equal to 0. Hence, x is equal to positive 3. And then x plus 2 is equal to 0. Hence, x is equal to negative 2. So that is why from negative 2 to 3, we have the discontinuity here. Hence, that is non-removable. Okay, so this is a radical sign again. Next, we have a jump discontinuity, which is non-removable. So again, meron tayo ditong piecewise function. May piecewise na siya, tapos ganito pa yung symbol niya, walang equality. Expect that there will be a jump discontinuity, or that is non-removable. Usually, it is dito, dun sa pinag-approachan nilang dalawa. Okay? X is equal to 1. So that is your hint, ano? Kapag walang equal sign, or there's no equality on the sign, sigurado jump discontinuity na yan. And that is non-removable. Okay? So another one we have here, a piecewise equation. Again, approaching negative 1, negative 1. This is an essential discontinuity or infinite discontinuity kasi as you approach negative 1, yun na. Wala nang value. Okay? So, may divider ka na 0 dito. Therefore, discontinuous na siya. Ibig sabihin, it will not touch negative 1. This asymptote here. Okay? So, hence that is non-removable. And then, when dealing with piecewise functions, we must consider where functions changes. For example, here. Okay. Although may piecewise tayo dyan, there will be also this continuity in that. Okay. So we must have also to check that one. Although meron tayong open dito, for sure, this one. There will be a continuity here because this touches this point. But this approaches that point also. Okay? So for another piecewise equation, with x is equal to 4, where's 4? This is positive 4. If still this is continuous, okay, given this equation, x is equal to 4. Because we cannot apply x is equal to 4 here because it's already set that x is not equal to 4. So dito lang siya mag-apply. So therefore, this is still continuous. But in this case, pag sinubstitute mo yan dito, asymptote na siya dito. X is equal to negative 4 with this equation. Okay? So it depends really on what is the value of the function. Okay, so there are also special cases limits, wherein limits as n approaches infinity, the area of the polygon will be equal to the area of the circle. So if n refers to the number of sides, that is inscribed in the circle, the side length is not equal to the arc. Itong linya na to could not be equal to this. Siyempre, mas mahaba tong kurba na to. Okay? Eh, kung gawin kong 12 yung sides, still, hindi equal yan. Mas mahaba pa rin yun. Okay? Eh, kung gawin kong 36, halos parehas na. Side length is now almost equal to the arc length of the circle. Note that n can be set to infinity since sides are still in a straight line and cannot be a curved one. Kahit napakaraming side niyan, it will never have a curve. Straight line pa rin yan. So that is the principle here. So the limit when the number of sides of a polygon approaches infinity, the area of the polygon will be equal to the area of the circle. Okay? Ngayon, pag dinagdagan mo pa yan, pag ginawa mong 100 yan, halos parehas ng area ng polygon to the area of the circle. Okay? Hence this function. So there are also special case limit. So that is the limit when the angle theta approaching 0, sine of alpha all over alpha is equal to 1. So to illustrate this, let us have here, see, this is point O, this is point A, and that is point B. I will just delegate the angle as dividing a triangle with a bisected angle alpha. So ito yung alpha natin. So by that, we write the formula. So for a certain length, arc length, see, this is theta. So remember that the arc length could be proportioned to the whole circumference of the circle. So remember that the arc length is just a portion. See, this is a portion, theta. And circumference is actually 360 degrees. So stand to that principle. We have the arc length this way. Perhaps we can have that one as AB. The arc length is 2 alpha, because there are 2 alpha there, is equal to circumference. What is the circumference? 2 pi radius over 360 degrees. We express 2 pi in terms of degrees, and I think this is 360 degrees. So that we can cancel that portion, and then by cross multiplication we have AB. The arc of AB will be equal to 2r alpha. That is equal to 2r of alpha. And then for the area or the length of this AB, A to B, or line segment AB, so chord AB so I'm going to have point C here. You can say that AB is equal to AC plus CB, wherein AC is actually equal to CB. It's the base of the right triangle. Okay, so if this is the right triangle, this is alpha, angle alpha. So this is AC. Okay, this is the point of origin. So we can relate this by its radius in terms of alpha. So we can say that sine of alpha is equal to opposite is AC all over hypotenuse, which is considered as the radius here. So therefore AC is equal to R sine of alpha. And knowing that AC is equal to CB, therefore multiply mo lang dalawa eh. AB here is equal to dalawang R sine of alpha. Okay, so line AB. Now if our angle, pag lumiit ng lumiit yung angle natin, if our alpha approaches 0, therefore we agree now that AB, or the segment or the chord AB, would almost be equal to the arc length. Okay, so AB will be equal to the arc length. Kaya ngayon naging we have 2R sine alpha is equal to 2R of alpha. Hence we can cancel that R and that 2 there. So therefore, dividing both sides by alpha, we have sine of alpha all over alpha. This is equal to 1, which is this one. Okay, so that's the explanation. So habang lumilit yung angle, lumalapit ang value ng arc AB tsaka nung chord AB. So that's the principle here. Okay, so special limits, we have 0 and infinity as limits. Ano bang ibig sabihin ng infinity? Ito yung infinite value, meaning napakalaking value niya. Okay, so if we set that V approaches 0, tapos yung V mo nasa numerator, okay lang yan. So a 0 is divided by any number, no? The constant here will always yield to 0. So remember that. And then if we set V approaching infinity, so I think this shall equate also to infinity. Sorry for that. Yan dapat. So ibig sabihin, kahit paghati-hatian mo yung 1 trillion, pagkatiyan natin dalawa yung 1 trillion, eh malaki pa rin yun. So ibig sabihin, it will just equate to infinity. Okay, kahit 10 pa tayong maghati-hati dun sa 1 trillion, it will always yield to infinity, or malaki pa rin yun. So that's the point here. So a large number divided by a small one, large pa rin yun. This is infinity. And then for the third, if we set our v also to be infinity, ngayon, pag minultiply mo pa yan, pag minultiply mo pa yung infinity sa isang number, therefore, lalong lalaki, magiging infinity pa rin. Okay? So that's the concept. So, for the number 4, if we set infinity, and then nandun siya sa denominator, magiging 0 na siya. So, what is the explanation of this one? Kung mayroon akong candy, paghatiin nating dalawa, manageable pa, okay? Paghatiin nating 5, so siguro yung candy wala nang matitira doon. Paghatiin nating 60, halos wala na. Paghatian mo pa ng mas malaking number, okay, infinite. Say for example, 5,000 na tao sa isang candy. So, it would equate to 0. So, as we approach infinity, the divider will be infinity here. Divide mo yung napakalit na number sa infinity, sa napakalaking number, it would equate to 0. So, para matandaan nyo, isipin nyo, yung C here is can be pinaghatian ng napakaraming tao. Okay? So, for the theorems on limits, simply, as x approaches a here, the function of x, say, be given as a, and another function of x be given as b, yung theorem, halimbawa, kapag algebraic sum or algebraic difference, you'll just get the difference and sum on or sum of the functions, whatever the integer is. Okay? Sa theorem 2, similarly, if we have a multiplication of two functions, it is simply the multiplication din ng dalawang result out of the limit as approaches an integer. And then for the theorem 3, as the limit approaches certain integer, if it so happen that we have a quotient operation, we'll just divide the result of their functions, provided that b will not be equal to 0. Otherwise, that will be considered as discontinuity. Okay, so that's about the principle on limits, which relates also to the previous topic, like functional notation. So, as a summary, we have found theorems on limits, the theorems of continuity and discontinuity, the types of discontinuity. Now we are ready to evaluate limits in details. So stand by for that, and thank you. Have a good day, class.